Okay, 9.3 is putting it all together. Which procedure do I use? So here's a little flow chart to kind of help us with this thought process. Which parameter are we estimating? And they've got proportion, mean, standard deviation. Here's what we're interested in this chapter, right? Proportion and mean. Okay, so if it's a proportion, right, then you need to check that this formula is greater than or equal to 10, and then you go ahead and construct your confidence interval. If it's a mean, you need to make sure, basically what we're doing is making sure we can assume it's normally distributed. So is your sample size more than 30, greater than or equal to 30? Okay, if yes, just complete your t interval, right? If no, then we need to go through that extra step. Do the data come from a population that is approximately normal? So we're going to look at a histogram and see if it's bell-shaped, and then we're going to look at a box plot to see if it has any outliers. Okay. If no, we would use non-parametric methods, which we don't do in this course, but if yes, then we compute our t-interval. Okay, so all this section is, I've got a few examples. We're going to do a couple with on the calculator and then a couple by hand, because I really need to be able to do them both ways, and that doing by hand, it helps enforce the understanding of what it is we're doing, and I really, really need that. Okay, so example. A simple random sample of size 300 individuals who are currently employed is asked if they work at home at least once per week. Of the 300 employed individuals surveyed, 35 responded that they did work at home at least once per week. Construct a 99% confidence interval for the population proportion of employed individuals who work at home at least once per week. Okay, so because we're looking for a population proportion, remember the first thing we need to do is see if this formula is greater than or equal to 10. All right. Okay, so also they didn't really mention this on our little flow chart, but we need this to hold also, that we need our sample to be less than 5% of the total population. So we're talking about employed individuals, and 300, well, that's way less than 5% of all the employed individuals, right? So this one holds. Okay, let's check this one. In order to do this, I've got my n, but I need p hat. Okay, which is our population proportion. Okay, so it is 35 responded that they did work at home. Now pay attention to this. It says construct a confidence interval for the population who work at home, right? So this is the number they gave us, but what if it said who do not work at home? Then I would need to use 65, right? Makes sense. Pay attention to what you're being asked and what information you're given. So 35 do work at home at least once a week out of a total of 300. Okay, so 35 divided by 300 is 0.1167, and because it's a proportion, 3 decimal places, right? Okay, so now let's just plug into here. We've got 300 times 0.117, and 1 minus 0.117 is 0.883. Let's see what that is. Oh, that's 30.99. So, yes, my conditions are met. All right, so once my conditions are met, okay, let's do this on the calculator. So here's what we're going to go into. We're going to go in Stat. Then we're going to go over to Tests. Okay. And then we're going to scroll all the way down through all the numbers. It starts over there with the alphabet to A1, prop Z, interval. Let me go way down there and see exactly what it says. Yep, so I'm going to choose that one. Okay. All right. Now, it gives me, here's what it gives me. It gives me X, N, and then C level. So X is the number that meet your condition. N is, of course, N, the number of your sample size. And the confidence level, we want confidence interval of 0.99. So I'm going to enter all those. So what do we have? 35, 300, 0.99. I'm going to go down and highlight calculate. And then notice right up at the top, it gives me my confidence interval is 0.069, 3 decimal places. It's a proportion to 0.164. Okay, so we are 99% confidence that this population proportion, right? 99% of them will be in this interval, right? Okay. A simple random sample of size n equals 12 is drawn from a population that is normally distributed. This one tells us it's normally distributed, so I don't have to do any of my checking, right? Otherwise, this would be a huge issue, but it says it is normally distributed. So the sample mean is found to be 45 and the sample standard deviation is 14. So construct a 90% confidence interval for the population mean this time. So for the population mean, let's do the calculator again. Okay, I've got my requirements met. So I'm going to go back in to Stat, Test. But this time, remember, it's the mean. We need the T. So let me get back in there and see exactly what it says. I think it says T interval. Stat, Test, and it's number 8. Yeah, T interval. All right, so then you're going to go over to Stats again, and here's what you see. X bar, standard deviation of X, in C level. So X bar, 45, standard deviation, S, 14, sample size is 12, and we want our confidence level to be 0.9. So let me enter that. Go down and highlight that calculate. And you get 37 point. Okay, so now we're doing the mean. What are we? Oh, it doesn't tell us anything about what our data is. So let's just leave a couple of decimal places, 0.74. to 52.26. Okay? In a random sample of 40 felons convicted of aggravated assault, it was determined that the mean length of sentencing was 54 months with a standard deviation of 8 months. Okay, we're talking about the mean again. Construct and interpret a 95% confidence interval for the mean length of a sentence. So I got to make sure this is normally distributed. But oh, look, 40 is more than 30. So I can automatically assume it's approximately normal. My sample size is sufficient. It's big enough. Okay, so I don't have any preliminary work to do. Let's go right back into the calculator again. Okay, so stat, over to test, choose number 8. Okay, enter our stats. Let's see, the mean is 54 this time. Standard deviation 8. Sample size 40. And I want a 95% confidence interval. Calculate. And we have 51.44 to 56.56. Okay. Okay, in a random sample of 100 estate tax returns that was audited by the IRS, it was determined that the mean amount of additional tax owed was $3,421 with a standard deviation of $2,583. Construct and interpret a 90% confidence interval for the mean additional amount of tax owed for estate tax returns. All right, we're talking about the mean again. So let's do this one by hand. That means I need to know that it's approximately normal, or I cannot do it on the mean. Okay, so 100, it's a sample of 100, which is greater than 30. We're good to go. Okay, now, because we want a 90% confidence interval, and if we're doing this by hand, let's think about what that means. Then that means that, right, this is 0.9, because the whole graph has to be 100. Okay, 1 minus 0.9 is 0.1, and here's half of it, and here's half of that 0.1. It's symmetric, so it's exactly the same. So if I take 0.1 divided by 2, I get 0.05. So this has to be 0.05 over here. This has to be 0.05 over here. Let's again think about what this means for our standardized population. Okay, so because it's the mean, I'm talking about the T chart that I need to look at. So for that, I need the degrees of freedom. If n is 100, the degrees of freedom is 99. Okay, so I need to look at my T chart. Let me uncover my T chart here. Okay, and so now, okay, and our T chart gives us this value to the right. So I'm looking for 0.05 across the top, and I'm going to go all the way down that column until I get to 99. Well, 99 is not one of my degrees of freedom in the far left-hand column, but I do have a 100, so I'm going to use 1.660, right? 1.66 is my t-value I'm going to use. That's 1.66. So actually that line would be right here. Okay, but that's fine. All right, now here's our formula for our confidence interval. It is plus or minus our margin of error, right? So here's the formula. So I'm just going to plug that information in. X bar is 3,421. Let's do the minus first so that we get our first one. Okay, minus. Now, T sub alpha over 2, right, is 1.66. S is 2583. Over the square root of 100. So we could just put 10 there, but I'm going to put it all in there. Let's see what this is. Put it in my calculator. Okay, so I got 992.22. Okay, and if I did this again, except with a plus, all I have to do is do a second enter and change that minus to a plus, and I got 3849.77. Okay, so you know what a great thing to do would be? Let's check those numbers on our calculator, right? So for testing purposes, do it by hand and then do a double check with a test. Nothing better than double checking yourself. Okay, so let's go into stat, over to test. We need the t interval where x bar is 3421. Standard deviation is 2583. Sample size 100 and 90%. And here's what we got on the calculator. 2992.1 and 3849.9. Okay, so 2992.2 versus 0.1, right? Rounding issues involved, so just slight decimals off is fine, but that's all. Okay, 3849.8, 3849.9. So either one of these would be perfectly acceptable answers. Okay, in a survey of 1,008 adult Americans, oh, hold on just a minute. Yeah, okay, sorry, I had to deal with something for a second. In a survey of 1,008 adult Americans, the Gallup organization asked, when you retire, do you think you will have enough money to live comfortably or not? Of the 1,008 surveyed, 526 stated that they were worried about having enough money to live comfortably in retirement. Construct a 90% confidence interval for the proportion of adult Americans who are worried about having enough money to live comfortably in retirement. Okay, so that means we're doing a population proportion. So I need to know that N is less than or equal to 0.05 of the population. Well, the population is adult Americans, and so 1,008 is way less than 5% of adult Americans. So I need to know that n times p hat times 1 minus p hat is less than or equal to 10. Greater than or equal to 10, I better say. Okay, and so let's see what our p hat is. P hat, now let's pay attention. 526 state they're worried about not having enough money. Construct a 90% confidence interval for the people who are worried about having enough money. Okay, so 526 out of 1,008 is 0.522. Okay, right? 3 decimal places, 0.522. So let's plug it in up here. We have n times 0.522. Oh, not n. I know what n is. This is where we're plugging in. So 1,008. Didn't really leave myself enough room if I need 1,008 on there. Okay. So 1,008. 0.522. 1 minus 0.522 is 0.478. So that is 251.5. Okay, so our conditions are met. Now, we're doing a population proportion, so we're back to the Z. Okay, don't forget that. Now we want a 90% confidence interval, so we want this to be 0.9, which the same as before. 1 minus 0.9 is 0.1, half of that. That means this is 0.05, and this is 0.05. Okay, now our Z table gives us this value, but it's symmetric. 0, 1, 2, 3, -1, -2, -3. So I've got those two choices. I can either find this one minus this, or I can just find this one. Okay, let's see. So let me get my Z chart. This time I'm looking in the middle of the table for 0.05. Right in the body of the table. 0. Okay, and -1.6, -1.64 is 0.0505. And 0.0495 is -1.65. So I need to go halfway in between there. So this is going to be -1.645, which means this over here is 1.645, right? Because of the symmetry. Okay, so now I'm going to plug into our formula. This time, our parameter is p hat plus or minus z sub alpha over 2. Our margin of error is represented a little bit differently. Okay, so 0.522 minus 1.645 square root of 0.522 times 0.478 all over 1,008. Let me see what that gives me. Okay, this is 0.496. And if I do it again and just change that to a plus, I get 0.548. So there's our lower bound or upper bound. Let's double check it inside the calculator. Okay, so I go to Stat, Test, but this time I need to go way down to A to get my Z interval. Okay, X is 526, 1008. We want to be 90% confident. Okay, so if I did it on a calculator, I got 0.496 and 0.548. Rounding issues on this one were even off on the 4th and 5th place. Okay, so that finishes up chapter 9, which means you now have test 3 coming up next. So let me know if you need anything.